Hello, everyone. Oops, my name is Mikio. So, touch the laptop.
Yeah.
Oh, good. Oh, it's just a cable, I think.
We might have actually put it into screensavers. Yeah, just left and right.
Okay. Yeah. All right. So I did actually. I started out as I did a PhD in machine learning in Bonn. Then I was a postdoc at the TU Berlin here, and then like 6 years ago, I joined Zalando and worked on recommendation and search and the machine learning platform. And then I was at GetYourGuide at the beginning of the pandemic, just for 9 months or so. So when you don't have a lot of customers or data, it doesn't make a lot of sense, unfortunately. And then after that, I became a consultant. So for the last 1.5 years, I've been working on all kinds of projects. So and I sort of did everything from like starting computer science, research, and all of that. Yeah, that's what I'm trying to help people with right now. And the title of my talk is what you need besides ML to put ML in production. So originally, what was the first version of the talk was just what we will hear later on. So lessons learned from building data science products. Yeah, so we had to find something new. All right. So what is the, maybe I move it, can I move it up here? Oh yeah. Right, so I think you might think, okay, what do you mean machine learning besides machine learning, right? Isn't it like, so we have AI, right? Everybody knows that. You've seen all the videos, and then you do something, and then you make a lot of money, right? So you would ideally, right? I know, let's say you want to create a new chatbot, so you download the paper, you pull the model from Hugging Face, something, maybe you retrain, and then you put it in production. That's it, right? Or so, but unfortunately, it's not that easy. And I think there are, or what I also consistently see, there are things that you also need to learn, right? So unfortunately, it's not sort of in a way we solve the problem, but not in a way that you can just take it off the shelf and use it yourself. And I will talk about, in the next 20 minutes, 18 minutes, about 4 different areas. So data collection, how to run data science projects, organizing teams, and to learn which tools to use and which not. So, and I think this is, yeah, it's all besides machine learning, because with machine learning, you usually already have the data set, I think. All right, so data. So as you hopefully probably all know, right? So for machine learning, you need, so it's a way of constructing programs that do something, but instead of writing the program, you let it learn from data. So who of you who has not known that from the people here? Do you roughly know how it works, or? Okay. Yeah, so you need data, right? So that's the whole point. So if you want to have something, so maybe you want to classify emails, or you want to build a recommendation system, or improve your rankings for an e-commerce, or I don't know, do something else, you always need this data. And if you don't have the data, the question is how you get it. And this is sort of my brain dump flow chart of trying to figure out, okay, what are all the options? So like the worst case is if you don't have any data, right? And it could be that, so you just don't have the data. So what you have to do is you have to start collecting the data, right? Or maybe you can buy the data, or you can somehow bootstrap your product in a way that you get the data. So let's say, and this is actually quite common, I think. So let's say if you're in a company, you're selling something, and you want to build a recommendation system, but you haven't collected any of the data, right? So you have some idea what works or what doesn't work, and then you have to start doing it. And it could be that collecting this data is actually really like a big effort. So you have to start, somehow collecting it. Maybe you already have it, but that's a different point, right? So this one word collect could mean like a 3-year project until you have the data where you can actually do something. So another case is you have the data, but not digitally, right? So I've talked to people who say like, yeah, we have like quality control. They wanted to do some quality control on some machines they have. And they said, no, it's not a problem, right? We have somebody check all the machines every day. But it turns out what they do is, so they fill in these paper forms with some stuff, and then it gets put somewhere. So you have to scan it, digitize it, and so on. It might be another few months before you have something. Or you sort of have the data, and this is, I think, the most common case. You have it, but it's not in one place. So you have to walk around and pull data from different databases, and that can also take quite long, because you have to figure out who owns the database, who can give me access to the database, and so on. On the other hand, so if you have some data, it still might be, you're still not done, right? So it could be that you sort of have data, but it's not labeled. So you have like lots of, let's say you want to do, so you get customer requests and you want to have a system that sort of tells you what it is, so you can route the customer request easier to the right person in the call center. And you sort of, you have like 2 years of data, but the actual information that you want to have is not there, right? So luckily, I think in this specific case, maybe you have a database somewhere else where people actually said, okay, what it is, but often you also don't have it, right? Or if you have, if you want to do computer vision to figure out, I don't know, defective elements or something in production, then these are usually not labeled. And then you have to hand label them in the worst case, right? So you have to have experts in your company look at the data and then label it. Or you can sometimes also crowdsource it. So you can, there's this thing, Mechanical Turk from Amazon. It was one of the first, I think already like years ago. And essentially you upload your data and then it is shown to people. So people can look at the data and then they can label it and then they get a few cents every time they do that. Yeah, and sometimes this is the only way, right? And you have to, then you can also be smart about it and start like with a small set and then figure out if you have enough and so on. All quite complicated. So you could also have data. So I think the standard example is if you have like a website and you want to build a recommendation system. So you have all the tracking data, but then you realize it's very faulty or incomplete. So there are some events which are not tracked, right? Or there are mistakes in there, so you have to fix it another few months. Or you might also have data, like medical data, but there's a lot of privacy issues. So you have to figure out, okay, maybe we need to change contracts with our customers so that we can actually use the data and so on. So it could all be quite complicated. And I think so what you need to learn is sort of to figure out which one of these you have, and then figure out a good way to do that. So by the way, if you have any questions, you can also, of course, always interrupt me. I want to talk a bit more about this Bootstrap thing, which I think is quite, I've seen this a few times, which is quite nice. So the idea is, so you have a product and ultimately you think, okay, that's a great thing. This is something where we could really use data and machine learning and do all of that, right? But you don't have the data. So instead of, but what you can do is, so you can build versions of your product that so the first version of the product doesn't use any machine learning, and it's just there for you to start collecting some data, right? So an example was at Zalando, they talked about it. They had like normal recommendations, and now they wanted to build outfit recommendations where you don't just get like one piece, but sort of like a matching set of items. But they didn't have any information on that, right? So they thought about, okay, maybe we can look into what people bought together and somehow reconstruct it and so on, but they didn't really have something. So what they did instead is they said, okay, let's start just like with an outfit recommendation, which is sort of fed with hand-coded data, but just to make sure that the product itself looks nice and is right? And then, so once they had that out, they had something which they could use to start collecting data. So the second version then uses like some of the feedback from the first version, maybe to do A/B tests, to do some tinkering, maybe add other data sources, and then you have the first version, and then from that you can start collecting the actual tracking data, and then you can at some point do the full machine learning model, right? And I think there are different versions of that. I once talked to somebody from SiteGold, was a German startup to help like restaurants with their accounting, and they also had some version where there were humans in the loop who looked at the data and then sort of you grow your data set over time. There's also an anecdote that Amazon, they have this Echo line of devices, and then at some point they had one where you could do like a portrait mode picture, take a picture of you. And they said like, oh, it's great, you can take a picture of you and then share it with your friends and they can see what you're wearing. But at the time, people said maybe they're also just trying to collect like collections of people wearing something, and then they would use it later on. So so I think this is a bit more advanced, but sometimes that's also the only way. And if you figure out how to do that, I think it's very nice. All right, data science projects. So this is now in my consulting work, unfortunately, one of the most common problems is that people don't understand that data science projects are really different from normal software engineering projects, right? They think, okay, maybe we hire data scientists, but then essentially we do just the same thing. And the difference sort of is, or the like typically, or those of you who maybe have done a data science project also know that it's a very iterative process, right? So you start with some problem and you think about, okay, how can I reformulate this as a machine learning problem? You get some data and then you run some experiments. You have some idea, okay, I could use this method, and then you see, right, you do like a first batch of that, hopefully very quickly. So hopefully you already have the data. This is after the 3 months you waited to get the data from that one database where they didn't want to give you access to. Okay, and so if it works out, right, then it's okay. You can take more data, think about how can I put this into production and so on. But more often than not, it does actually not work out. Right? And then you have to think about, okay, what is wrong? Is it the data? Is it the wrong method? Is the problem formulation wrong? And then you start doing this iteration till you get there, right? And then very often it's like, because the data is always a bit different, you can't really predict how this is going to be, right? So I think that the basic point is, so there are like projects which are more about execution, right? So you can plan and predict how things are going to work, and there are projects which are more about exploration. So for example, assembling a car, planning a party, doing payroll, right? These are all like processes. It's clear what needs to happen, and you can predict how long it takes, how many people you need, and then you can do it, okay? And in a way, software engineering is often in that space. It's sort of like, you give me the requirements, right? I know how to put all this stuff together, and then you get it. Then it takes twice as long, but in principle, it's more or less clear how it goes, right? But exploration, on the other hand, if you invent something, if you start a startup, it's really not that clear. So the path isn't really clear, and that's the big difference. In data science projects, for like new data, new challenges, is always a bit in the second part, more or less. Okay, now the question, so how do you do? How do you approach these projects actually? And I think so what you need to do is you need to sort of, you need to figure out like what are the highest risks and the biggest unknowns in your data, right? And then you start sort of on the problems, on the stuff where you know the least about and which poses the highest risk. So just an example how that could look like. So this is like one project. So here, the highest risk, biggest unknown is the data. You haven't really looked at the data. The method, like the model, could be a high risk, but you found some papers that solved a similar problem. That's okay. But then stuff like deployment, right? So you've done it before. You used MLflow, some tool. That's okay. And then performance, you know, you don't really sort of, performance, it's really no risk, because you have very little users for that endpoint for whatever reason, right? And then in this case, I would say, okay, you have to start with the data. You have to figure out whether you have the data and so on. And then you can slowly move your way through it. Could also be a different project, right? So I worked on search. Sort of learning to rank is one of the approaches where you use user feedback to figure out what the right ordering is for a search term. And this is one example where it's really, really complicated, like technologically, how to integrate machine learning. Okay, maybe you say more about this.
I'm just really glad someone else is saying bike shedding besides me.
Yeah, yes. So, if you're working on something that is sort of unknown, but really nobody cares about, then you're in that area. Right. So and here maybe the data is okay. You have it. You know that you have good data. You used it before, so that's really not something you should focus on. And then this is sort of, so you pick like what is the biggest risk. You try to solve that. You time box everything, that you don't spend too much time on the project, or that at least after some time you ask yourself, is this really worth it or not? And that's sort of the approach. I think at least in the beginning of data science projects, how you should do it. All right. Teams. What am I doing? Okay. All right, so now sort of you have the data, you roughly know how to do the project, now the teams. So the biggest challenge I always see is, because of like the work is different, right? So you have this exploration, and software engineering is more about building stuff. And that's like just a cultural clash you always have. So software engineers, they're like, yeah, we want to do like best practices, you want to have it maintainable, want to have good processes, everything has to be reviewed and so on. And data science is more like, let me try this thing, and then tomorrow I try something else, and then all the code I've written in the meantime I will just throw away because it was just for me there to learn it, right? And if people don't understand it, there will always be these clashes between these two factions in the team. I think what you should strive for is cross-functional teams where you have data scientists and engineers in the same team, working on the same problem, that they really own it and they can also help each other. And usually, yeah, I would say so. There's a version where you do sort of agile software development with sprints, where data scientists and engineers are in the same sprint. And the only difference is, so for data, so usually you say, if you do agile, you say like after each sprint, you have like one increment, which you can demo and test and bring to the customer and so on. And for data scientists, sometimes this increment can just be some insights, right? So they say, we want to know, like, what is this version, like, of these 3 different approaches, which one is the best? And then you say, after 2 weeks, you want to know, get the insight, want to know what it is. And that's how it works. Yes, and I think you need sort of data scientists who want to learn how to code and engineers who are interested in working in more experimental fashion. And if you find those, I think then you can have great teams. So if you scale out a little bit, now on the right picture, so if you like on a whole company level, right, how do you do that? I think usually companies start with a version where they have all the data scientists in like a center of excellence or kind of thing where they work on prototypes. And the reason for that is that it's quite hard to find data scientists, so you can't just hire one for every team which needs them. And they also always want to have somebody to talk to because of all the exploration and discussion. So you have them there. And then the problem with that approach is that it's good to do prototypes, but then once you want to hand it over to the actual team who is using it, there's always this friction, right? So the team already has a plan, they don't know what this new stuff is, and so on. So over time, you want to get to the picture down below with the cross-functional teams. And there's also a version which I've never seen work anywhere, where sort of data scientists, they just do data science, and then they sort of throw it over the fence, and then you have people who are building the model, they throw it again over the fence, and then you have people who run it, right? Yeah, but I've never seen that. Maybe it works if your whole company is already structured like this. So I know people who worked at Twitter like years back, and they said actually they are like in a sandbox, so they have all the data, but they don't touch any production system, and they can work on something, and if it works out, somebody else picks it up. Yeah, but I personally haven't seen that work. All right. Now finally, technology. So the problem with machine learning is that there are just many, many tools out there. Sorry, I forgot to put Gina AI in the specialized ML libraries toolbox.
It's never too late.
It's never too late, yes. So this is just for another talk I did, right? I just, like, whatever I found I put down here, and I think you can maybe put like 5 times, 10 times as much products in each of these boxes. Yeah, and somehow, I don't know how people do it, right? So you have to really learn a lot of different tools, and it's sort of unclear what a good sensible subset is, sort of a way to start. And that's the sort of the money slide. So either because this slide will save you money, or we will spend a lot of money on cloud services. So yeah, in my opinion, so my recommendation, I mean, this all depends on like what is your problem, how much data you have, and so on. But sort of Jupyter Lab, that's like what everybody's using, just the notebooks to get started. Pandas, if you have enough memory just to hold your data in memory, use that. Start using S3 very early on. I think so. S3 is the storage in the cloud. So this is just for like the first step into the cloud, even if you're doing stuff on your notebook, laptop. So scikit-learn, I think, is for the classical machine learning, just the standard. TensorFlow, PyTorch for anything with deep learning. There's this library MLflow for logging and tracking experiments from the Databricks people, which I think by now is quite good. So they, Databricks, they have this extremely successful and aggressive sales force. So at Zalando, they came by every 2 months and said, "Don't you want to buy more stuff from us?" And then one day they also said, we also have this shiny new library, but it was like 2 weeks old. So that was maybe a bit early, but that was like 3 years ago. Yeah. So once you have all of that, at some point you will start about, okay, I want to also have to automate it so that the training happens every day. If you're at that point, right, I think everybody is still using Airflow, although it's a bit old. So you can tell it hasn't been redesigned or it has been designed at a time when there was no Kubernetes and stuff like that. I've looked at Prefect, which is also a library where you can define pipelines and run them automatically, which is quite nice. So one question always is, if you have a model, how do you access the predictions? And most tutorials tell you to deploy it as a REST service. It's quite easy. But there's another thing. So if you can also just pre-compute the predictions and put them in a database, and you never have to deploy the model. Very nice. And then my last recommendation also for this talk is sort of, as much as it hurts, don't invent the wheel at first. So the point is, so I mean, every time, so I've been working in this space for quite a long time. I've written like several versions of machine learning libraries myself while I was still a PhD student. And it's still, like, as I said, it's still like many different tools. It doesn't fit together very well. So every time I look at it, I'm like, maybe you should just rewrite everything yourself. But of course you shouldn't. I mean, until after you have something running, and then of course you can spend your time on rewriting everything. All right, so this is the very short, condensed version of what there is besides machine learning to do machine learning. Thank you very much.